Okay. Okay, sorry for the okay, I got a 35 more minutes, just battery finish. Okay, this is the difficulties that we need to face, huh? Okay, I'm just recording. My camera is not that good anyway, but it's very helpful anyway. It's very helpful during this time. Okay, just let me continue. Okay, in order to calculate the tangent line, okay, to get the tangent line, we can combine, as we know, okay, the FR times with the DR. Okay, this is a DR, right? The point here, we know this is the tangent line for this can be calculated for the DR. Recall back what you already learned. Okay, F times with the DR, dot product with the DR. Okay, the DR is basically, okay, total. Okay, we wanted to get the combination of the dot product. Okay, all the FR can I combine to the DR here. Okay, that's what we're going to do. Okay, that's what we're going to do. Therefore, the DR here is a dxi. Okay, dxi plus dyj plus dzk. Okay, the combination. Therefore, in a simple things, what are we trying to do is we are trying to make it parallel. Okay, parallel between F and DR. That's what we are trying. Okay, make it parallel. Therefore, calculations, we want to know how much force the line, basically the particle, is carrying on this line curve. Okay, therefore, we found a new formula to calculate this. In order to calculate, to make it the scalar, you can see the work can be calculated based on the F. This is the new formula which is very useful to you. Okay, we're going to see this is a very useful formula where we're going to calculate the tangent line. Okay, now you got the reason why we are using dr, not a r. Okay, we are using dr, okay, because it's a tangent line. Okay, we wanted to calculate the tangent line. This is actually dr. Every time when we calculate this as a dr, that's why we are calculating for the f. F is a tangent. We wanted to see parallel line. Okay, combination of this. Therefore, overall, as we know, this combination, it's not anymore vector. Okay, do you notice this f is a vector, dr is a vector. You can see f. Okay, I'll try to write for you this equation, at least you can see this. This will produce B A dr, right? Okay, f is basically is what? F is a f1i plus f2j f3k. Okay, combine these two, I will get this as f1 dx, f2 dy, f3 dz. Oh, this is a scalar. Okay, it's a scalar. Therefore, here I want you to see this carefully. The first intro, now I already move into the method number 3. Is actually, this is a method number 1. Okay, sorry, method number 2 that I wanted to introduce. But now I already move into the method number 3. But actually, this is the first formula that I want you to know. Okay, I will call it method number 3. Okay, this is very helpful to you. I segregate this to this way. It's easier for you because at least you know, you never confuse. At least you know, oh, okay, this is the method is a f dot dr. Both are vectors. Both are vectors. Vector, vector. Okay, both are vector and vector. Okay, method. Some of them may ask, sir, why are you splitting that for the several method? Can I incorporate and say this is the overall method 1? No, I just keep it this separate. Okay, method 3 is a similar, just the same. Okay, the same one, but I'm adding this. I'm adding this inside, which is, you see, there is a slight difference between this. Method 2 is vector, vector, but method 3 is a BA f1 dx f2 dy plus f3 dz is a scalar. Can you see? This is scalar. It's already converted into scalar. Okay, can you see that? That's why I'm changing this. This is a scalar. This is a vector. But don't worry about this. Okay, do not worry. But later I'll teach you the steps. You may be a bit worried. So I cannot sometimes see. Okay, suddenly you are saying scalar. Suddenly you are saying vector. Well, very simple. Stick to these logics only. Okay, stick to the logics. You can say this is a vector. This is vector. I dot product these two. When I dot product these two, I will get a 1, jj I get a 1, kk I get a 1, then I times these two, I get this. Therefore, it's very obvious this one is not a vector anymore. Can you see this? Therefore, this is not a vector. Therefore, I segregate this form because the first form we're going to use this is as a standard form for the calculating the work. Okay, for any calculation of the work, it's going to be this standard. Okay, vector times with the vector. Some cases they will use vector. At least you know, oh, vector combination. In the most of the cases, you're going to see this combination, which is a scalar base. Okay, this is a lot of in books. Normally, they won't specifically segregate this to the method as I'm teaching now. Okay, you look through few books first, then you may agree with me. Okay, because the books actually they will start showing you all the combination like that. Okay, but I'm trying to be careful in this because there is a step by step works here. Okay, now I'm going to show you some example for this, and later we will move into this example number 2. Okay, I will detail out this. Okay, as I say, example number 2 is a very detailed. Okay, but method number 3 we're going to use for the almost all the cases that we're going to use method number 3. Okay, now I'm going to show you some examples. Okay, I'm going to show you some example. Okay, let me show you how we can solve this using method 3. Okay, evaluate. Okay, evaluate if f x plus 3y I from a 0 1 to b 2 5 along the curve y equals to 1 plus x2. Okay, it's a slightly different from what you learned before, but I just show you what is the idea of this. Okay, let's say this is example. Okay, I'm using one single approach here. See, it's using one force only. It's a force, one side only. Okay, towards inclined to x side. Okay, therefore let me sketch this. Okay, we just sketch and imagine what is going on. Okay, how to sketch? Okay, how to sketch first? Okay, along this curve, can I sketch this? Okay, I want you all to learn the skill of sketching. Okay, sketching will be very challenging to you. If you don't sketch properly, sometimes you also tend to confuse bit. Okay, can you sketch this or not? Very basic, right? Okay, 1c x power 2 is a curve. Therefore, can I draw this side? Can, because, but you know I'm focusing here a1 to this. Okay, 0. Therefore, the point here is very obvious. 0 1. Okay, this is a 0 1. If you place here, can you check back again? Okay, if I place is a 0, y become a 1. Correct, right? Therefore, I'm looking at a is a 0 1 referring to, right? Then they want you to go up to this x. This is x2. Okay, Learn the skill, simple. Just substitute and see what is the next point that you want to looking at. You are looking for, therefore 2, and of course it's a 5 there. Okay, when you place that, you get a y is a 5. Then the b is here, 2 to the 5. Okay, now how do we know that basically it's a from, right? They say A to B. Actually, the curve is moving up like that. Okay, remember A moving to this B. This is very important. The direction is very, very important. That means the person, the ghost is actually going up. Okay, it's going up with this, like that. Okay, now how to calculate this? How to calculate this? Okay, the first thing here, let me try. How many methods am I learned? Sometimes students get, oh sir, you taught us many methods. I'm not sure which method to apply here. Okay, let's say so far we learned 2 methods, right? Let us combine and see. Okay, okay, let us try the first method, dr. Okay, is this a vector? Yes, this is vector. I know vector. Okay, is this a vector, dr? The curve is a vector? No, no, actually this is not a vector anymore. Therefore, I don't know, this is not a vector. But we know this is a vector. Is a vector given here? Is it a vector given here? No. If no, then immediately I switch to another method called this. f1 dx is a scalar method. Okay, dy f3 dz. Okay, which is a scalar. Okay, scalar. Okay, now we know dy is not applicable in this case because y dy is not there, because you can see I. Okay, it's only I. That means we are referring to the f1 dx base only. f2 is not exist, f3 is not exist. Can you get me? Can you following me? Okay, some of you saying, oh sir, still. Okay, again you see this is a I. Okay, when f, we got only f1, very obvious, which is referred to the dx. Therefore, we're going to use this formula. The work can be calculated based on the b to the a, whereby I calculate f1 refer to dx. Okay, refer to dx. Okay, how to calculate this? Okay, it's a reference to dx. That means my whole reference will be dx base. In this particular case, of course, we're going to use straight. Therefore, it's nothing much difference here. Okay, what is b2? Actually, what am I referring to here? Remember, my I is placed here. Okay, my I is referred to dx base. Therefore, I'm not going to say the base. Sometimes arrow is play the role, but in this particular case, I want you to know which one you are referring to is actually dx base. Therefore, f1 is very obvious, is x plus 3y. Okay, dx is 2 to 0. Okay, 2 to 0. Why 2 to 0? Okay, the line is going up. Okay, the line is going up. Okay, to the b. Therefore, it's a 2 refer to the 0. Okay, then shall I able to calculate here? But cannot. I cannot calculate here. There is a problem here, because I'm referring to dx, but y is here. Okay, y is disturbing me. But we know y is 1 plus x2, right? We can, therefore, I can substitute this x plus 3, y is 1 plus x2 dx. Okay, then I differentiate this, I will get x2 over 2 3x x3 and 2 over to 0. Okay, whereby I'll get this answer is 16. Okay. Okay, now I'll give you some contradiction here, small changes here you can see. Just to give you some to strike in your mind, because let's say the question I change it to different. Okay, I just say from A to B, right? From A to B. Now I'm saying from B to A. I'm saying opposite. Okay, B to A. If the case is a B to A, okay, for this, just take, sorry, if I just say the case is a B to A, okay, it's the other way around. From here it go like that. Okay, is there any changes that you will see? Yes, the work will be different. Okay, the work will be different. Why? The calculation will be different because it's a refer. You see, we will refer 0 to 2. That means the 0 become the end point. We are moving. See, from the low we are moving to the up. That means we follow the arrow for setting this range. This is very important knowledge. I want you to make sure that you know this. Okay, arrow is playing the role. Again, I show you again. In this particular case, arrow is changed. Okay, arrow is changed. You must follow the arrow for your range. That is very important. Okay, for this case you must follow the range. The range must follow the arrow. Therefore, rest of the calculations are same, but only the difference you can see is a 0 to 2. Okay, that's what you will see as your solution in this case. Okay, now the based, some of you might say, sir, you use dx, okay, because since this is the question, now let me show you. I changed the question slightly bit into the j. Okay, into the j. Okay, let's say same question. I just picked the same question. I slightly changing that, and let, okay, maybe it's example 2, maybe this is example number 1, call it. Okay, if I call it let f to be slightly same question. I pick the same force, x to the 3y j. Okay, I'm setting the same previous question to help you to see how do we calculate line integral in a various scenario. Okay, if this is the scenario, okay, the way we need to use here, again similar, which you cannot use. Okay, you look at this first. X. Okay, now the arrow here, it changed. Same direction or not? Yes, it's still same, but you are required to calculate for the F force, which is a J. Okay, that means for the W, B to A, whatever. Okay, B to the A, F to the DR, which we cannot use here. Okay, but the B to the A that I referring to here in this case is, as we know, the combination will be F1. This is it F1 is a J? I'm referring to the second dy. Okay, therefore dx, we know F2 dy, F3 dz. Okay, I got a 20 minutes here, just to, because my memory, the memory of the card also running out. Okay, here I need to get this one. Okay, F2 for the dy, or can I refer the dy? Okay, I'm having some difficulties here because I got a combination of the x and dy. Okay, I should use certain combination to get the dy here. Okay, is it possible for me to calculate the dy base? Yes, let me see. Here 3y dy. Okay, in a simple things, how to calculate dy. Okay, the simple things, how to calculate the dy first, because y is known to us, because we just substitute. Can I calculate the dy? Yes. Okay, we know y equals to 1 plus x2. What is the dy? dy is 2x dx, right? Can I substitute the dy here, this dy inside this equation? Can. Therefore, the whole equation now, still I'm referring to x base, again, not a y base. You may say, sir, can I convert this? Okay, put it the argument first, aside for a while. Just we try to refer to x base. Therefore, when you try to face this x base, still same calculation. You can see 2 to the 0, x 3. The combination here is a 1 plus x2. Okay, but dy is a 2x dx base. Okay, please try to solve this. When you solve, I think you may get it. Okay, you just expand this and you try to solve lah. I think this is not a difficult one. When you solve with this, you may get 1 2 4 3. Okay, take it as an exercise. 1, it's a 1 2 4 3. Okay, take it an exercise. Okay, then you see what you able to come up with, because it's x is become power 3, then you just it become a power 4. Later you should able to calculate that. Okay, but the simple question here, okay, the simple question here is this. Okay, let me show you anyway. Okay, I continue the okay, let me show you the calculation anyway. Again, 2 to the 0, 2x2, just am I making the calculation correct? 6x plus 6x3 dx. Okay, then the expansions of this will give you 2x3, 6x2 to 6x4, 4 is 2 to the 0. I get a 1 2 4 over 3. Okay, next time I won't show you this, okay, because I wanted to focus more into the concept. Okay, I wanted to focus more into the concept. Okay, so far I get it, but still I haven't answered your question yet. The question is, can I use dy base? Can I use dy base here to calculate? No harm to use dy. Okay, you wanted to change this to dy, but let's look at this complication here. Why I don't want to change it? Why am I changing everything in the dx base, x base calculation? Okay, the x base calculation is, okay, basically you can see when I change it this, you look at this one. Okay, I change it the x, it's become a little bit complex. Y minus 1, I get a square root, which is not good lah. Okay, when we work with this kind of square root, the calculation become more complex. Okay, which not helpful to us. Is for the good for the integration and etc. Therefore, my preference I change to x base. Okay, therefore the question, your question is valid. Can I use based on the dy? Yes, possible. Therefore, you need to find the way to integrate effectively. Okay, later I'll teach you. You can convert to the any other method. Maybe you can convert it to the dy dx base or dx dy base, up to you, or you wanted to convert that to the parametric. Therefore, you have 3 choices to handle this problem. Okay, 3 choices. Okay, still we are learning method 3. We are elaborating on the method 3. Okay, let me go one step with the one more example. Okay, one more example. Let me finish this example. then later we go for the other method. I think we take a small break for a while, then later we continue, because there are many methods to explain to you. Okay, imagine, let me put it to you this, instead question I put it to you this. Okay, okay, curve, let's say there is a curve here. Okay, I combine this. Okay, let's say there is a ghost, okay, moving this y to the x. Okay, then this is a C1, C2 curve, C stand for curve, C3 curve, and let's say the ghost is moving up. There are two ways to go here. Okay, go to this point. Okay, the point I may call it here y is for x2. Okay, therefore the reference here for this, therefore here it's become 1 over 0. Okay, now what is the question? I didn't set the question. Yes, the curve 0 0 0 from the origin, it moved to 1 0, and from 1 0 to 1 4, and let y to be 4x2. Okay, what is the ghost? Okay, I should give you the ghost, right? Okay, you should be able to identify the ghost here. Therefore the ghost here is this: x2 plus 2yi xyj. Okay, okay, ghost is given. Okay, whether the ghost wanted to use this path or here, let us calculate. Okay, maybe some of you may ask one question before we making this calculation. I would like to ask this: is it same when I calculate C1? Okay, the work to moving from this point to origin, origin to A, maybe I may call it here A0 A B. Okay, is it the point 0 to B is the same as 0 to A to B? No, right? Can I say that equals to C3? Simple question. Can I assume? Cannot. Okay, let us try, and later we conclude. Okay, therefore the first thing to calculate the W here, okay, I say B0 FDR. Why am I repeating this again? This is a very fundamental formula, but you can see here there is a this is a vector, but this one is not a vector. Okay, therefore no other option for us. You need to use the formula, what I call it as a FDR, whereby we just go back to this A, which is F1 dx, F2 dy, F3 dz. Okay, but it's very obvious from here. We know F1 is there for the dx, F2 is there for the dy, but there is no dz. Okay, that means this one will disappear, right? This will disappear. Therefore, let us start our calculation step by step. Okay, to calculate for the C1. Okay, we're going to use C1 too. We're going to calculate the C1. Okay, curve. We're going to calculate the line integral for the curve 1. The calculation for the curve 1 is very obvious. From here it's a straight line, right? You can see it's a straight line. Therefore, few conclusions to be made here before we calculate. Y equals to 0. Okay, y equals to 0. If y equals to 0, dy equals to 0 as well, right? Can you get me? Okay, if it is a y equals to 0, of course dy is a 0. Okay, now in order to calculate the C1, which is a f dot dr, okay, which combination we can use? This combination, right? Okay, but now we know dy is a 0, right? Therefore this whole thing becomes 0. It will get back to the formula, which is f1 dx only be able to retain. Okay, because this one is a 0, therefore we are not going to use this. Again, I repeat to you, f1 f2 is exists dy. Let me write this anyway for you to know. f1 is there, x2 plus 2y dx. f2 also exists here, xy, but dy is a 0. Okay, the changes at the dy is a 0. Therefore this will disappear. Okay, once it's disappear, now can we change it everything here, and we know y also is a 0, and we are using x base, x here, the x base. Okay, therefore can I calculate that? What is the x here? Okay, 0 to 1. Okay, 0 to 1, 1 to 0. Therefore this become x2. Again, don't ask me again where y is a 0. Let me write here 2 to the 0 dx. Therefore the solution for the C1, okay, for the C1 is 1. I hope that you can calculate this part here. Okay, please calculate this. 3, calculate. Okay, then you should able to solve it by yourself. Okay, it's a 1 over 3. 1 over 3. Okay, now shall we able to calculate C2? Okay, shall we able to calculate C2 again? Okay, C2, look at this again. C2, there is some work to be done. Okay, let me keep it this here on the top. Okay, I'm going to use this one. Okay, let us see. C. Okay, overall. Okay, the C2, in order to calculate C2, okay, based on the, can you see that? Okay, in order to calculate C2, maybe I just fold it more. Okay, I hope that you can see the C. In order to calculate C2, again I go back to the same logics here. Okay, C2, what is the important things that I can see here? X equals to 1, right? X equals to 1. And what about the dx? Dx is 0. Dx is 0, no changes inside here. Therefore, very obvious, go back to the C2 calculation here. It's a B2 something we call A, whatever, f dot dr. There is both no vector. Okay, therefore we go back to again the logic that we established here, f1 dx. Okay, I'm writing this again and again, dy, because later I'm going to introduce different formula. That's why I'm repeating this again and again. dz, no z here, forget this. Okay, what about dy? Dy is exists, dx is a 0, therefore the whole thing become a 0. Therefore the dy is a xy, okay, and to the dy. Okay, and since we know x equals to 1, we just substitute here. And I see some of you may ask, what is the range? What is the range for this? Wait, on hold first. Okay, x is a 1, y, dy. Okay, now our base is, we are looking at from which base? Dy base here. Okay, here, this base. Okay, what is the range here that we are referring to? 0, to 4. The arrow is moving up, therefore here is 4. How do I know it's 4 here? Okay, you substitute and see. Okay, when you substitute f x here, okay, you see y equals to 4x2. If it is a 4 1, you get a y equals to 4, right? That means it's a 4 to the 0. Therefore when you solve this, you get c2 equals to 8. Okay, c2 equals to 8. Okay, calculation. Okay, I don't have much time here. Okay, I don't have much time here, therefore I need to show very quickly the next part. Then because at least is easier, because the recording will stop within 6 minutes from now. Therefore let me, okay, how to calculate C3. Okay, the later portion I'll explain to you in next sessions, you see. Okay, now how to calculate C3. Okay, C3, look at this again, look at this one. Okay, C3 is a arrow is moving up here, therefore it's a well known here is we are using this. Okay, what is dy again? Dy can be explained as 8x to the dx. Okay, this is the equation that I have. And can I use again for the C3 f dot dr? Cannot. And we know basically I can use f1 to the dx, okay, f2 to the dy. Okay, place everything again. Okay, here x2 plus 2y dx plus xy dy. Okay, okay. With respect to the dx is easy. Okay, now we have a two choice. Which choice will you go for? We have a dx base or dy base. Okay, you cannot, okay, maybe you can say, can I choose dy? I can go to this and substitute and I calculate, because you know, okay, try to understand. Okay, this is possible to write this way again. x2 dy dx plus, okay, xy dy. Therefore up to you, I leave it to you, because I can split this. Okay, this is the property of integration. You can split this to the two. Now you can focus to the dx and dy base. Let's say you prefer to use dy, it's up to you. Okay, I leave it to you. Okay, you wanted to use a dy here, can. Okay, but my preference here, this is, if I change it, convert all the y to dx base, can. Okay, some of you say, no, I would like to use, but you see, it's a little bit complicated. Y divide with the 4 square root is x. Do you prefer this to substitute here? No, I don't think I prefer to do that. Okay, therefore, find the easiest, okay, I may say, again, I repeat, find the easiest things, easiest way to solve. Okay, therefore, I put a note here. Find the easiest part, or with respect to dx or dy or something here in this case. Okay, easiest part. This notes is helpful to you, because I don't simply go and trap yourself into the completely a complex problem. Okay, I got 3 minutes. Okay, then okay, I expand, just substitute. I will get it here, x2 plus 2 4x2 dx plus x 4x2 8x dx, where this is actually is a, what is the size here, 0 to 1 again, still. Okay, the arrow is moving up, therefore is something that we are referring to this side, 0 to